Do I push forward here?
Yeah.
So, good afternoon. It's a pretty good crowd, so let's move on forward. There are other speakers coming. Actually, there will be a row of 3 Swedish speakers for some reason right now. I will be talking about high capacity coverage for TETRA and cellular services in large venues. And I think for some time now, TETRA has gone parallel ways to cellular services in quite a lot of venues. I will be talking about some of the examples and what we should expect in the future. Briefly, what Axel is doing, for anyone who doesn't know the company, we are a European manufacturer and supplier of coverage solutions. The company has a portfolio consisting of cellular solutions as well as public safety. We do VHF solutions, UHF solutions, FM radio broadcast, DAB and others. And we also provide nowadays coverage for LTE. So key areas of focus is public safety, transportation, and cellular services. TETRA is one of the largest areas for our company. We provide coverage in metros, in airports, and all kinds of these large venues, and of course in newly built buildings or venues. The use of cellular is also very interesting. I'll be talking about the various venues and the coverage solutions you should apply to them. Also talking about distributed antenna systems, sharing infrastructure and cost, some examples around that between cellular services and public safety, and also some of the requirements and differences in requirements between cellular and public safety coverage requirements. The various venues, I've just taken a few examples of venues where you accept to have or expect to have both public safety and cellular coverage. The building to the left is actually a police center in one of the cities in Sweden. The one below that is a big airport, as you can see. The tall building in the middle, you all have seen that already, and the one to the right is an entrance to one of the stations in the Stockholm Metro. And now in the left corner you see a picture of a stadium, a rather large stadium, which is a hot topic in those days to talk about. So let's start with an airport, and I've taken one example just to mention what challenges you get when you build a new structure, a new terminal, and you want to provide radio coverage inside it. This is Heathrow Terminal 5, built a few years ago. It's already 5 years or something like that. So besides the building itself, the main building T5A, you also have satellites beside it, T5B and C, and there is a new area to be planned. The original structure of this coverage was for cellular, public safety, and several other services. So we have P25 TETRA an MPT 1327 analog trunking systems. And it should not only cover the Heathrow terminals themselves, but also Heathrow Express, you know, the train going from central London out to Heathrow. Some road tunnels next to the airport terminal also needed coverage. And between T5A and the two satellites, there are driverless trains running. So these tunnels also needed systems to be covering it. And this was a giant distributed antenna system with a base station placed in one center and the signals being transported over to the remote areas over fiber. In the long tunnels, the normal way to provide coverage is by radiating cables. They provide consistent coverage results, and they are very predictable. But also in areas which are more square, it's common to use antennas, of course. So this solution was a combination of all kinds of radiating components. Why use a distributed antenna system instead of putting base station on each place? Here is one example, and it's relating to the situation of TETRA. In this case, we've taken a few buildings, and to provide coverage in each of the floors, we put one TETRA base station. This is one channel base station, so it has three available time slots. In this case, the people inside each of the buildings can communicate over that base station. If some of these users are now connected in a call group, a group call, we call it A here. That means that these individuals who belong to that call group are occupying one time slot in each base station. So 1/3 of the capacity actually of these base stations is being used by that call group. If we put all the base stations together and make a so-called base station hotel, which is becoming very popular, so we increase the capacity in one place, and now we distribute these signals out to all the individual building parts. That means that anywhere where the users are, they have access to the entire capacity of the whole base station hotel. And in this case, this call group actually only needs one time slot out of the entire capacity. So it shows just one example, which is very much related to TETRA because of the group call capability. But I will explain a little bit about how a base station hotel with distributed antenna system works perfectly in other areas. Let's take sport arenas as an example. This is one picture of an arena in London. And for the Olympics, there are requirements to provide, as we've heard before, 2 TETRA networks, one public safety and one network which is going to be used by the organizers for the entire event. All the UK operators, of course, also want coverage in the sports arenas, as in any country. We have examples from the US also, just recently with big games where the capacity requirements they are simply exploding because of the use of smartphones nowadays. So the UK operators have no LTE at the moment. The frequencies have not been auctioned. Actually, the LTE frequencies in the UK are being used for other services just during the Olympic Games. So the UK operators have to focus on 900, 1800, and 2100 megahertz. And the only way to create a capacity anywhere near what is expected in the future is by actually putting UMTS and GSM together, mixed on 900 megahertz. 1800 is used for GSM, and 2100 is already a UMTS band. So in the same way as in the other example of Heathrow, the base station are placed in a base station hotel. And the signals from all the base stations are distributed out to the area. In this case, TETRA and cellular services are really integrated into